Welcome to the Advanced Chroma Canvas course at Bambu Lab Academy. Having completed the beginner and intermediate modules, you are now fully capable of creating your own independent filament paintings. But we aren't stopping there. In this session, we are unlocking professional-grade techniques to ensure your creations are not only visually complex, but structurally stable. Have you ever faced this challenge? When working with complex patterns or images without clear backgrounds, the automatic segmentation sometimes falls short, often leaving you with blurred details, undefined edges, or muddy color transitions. In this lesson, we will master two core advanced concepts. First, the color wheel for precise color separation. Second, transmission distance for controlling color blending. By mastering these key skills, you can achieve professional filament painting results with delicate layering and vivid, true-to-life colors. In this episode, we're taking on this colorful parrot project. We will guide you through the mysteries of color wheel-based segmentation and transmission distance to bring this image to life. First, enter MakerLab, open Chroma Canvas, and import your prepared image file. For this red and blue parrot, we can initially divide the image into two distinct regions, the foreground and the background. Click to add a foreground layer, then select the color wheel to perform a fine separation between the subject and the background. Next, use the eyedropper tool to sample the red area of the parrot. You will see the pointer on the hue wheel automatically jump to the corresponding red segment. Now, adjust the range handles on both the left and right sides of the wheel to fully enclose the range of red tones you want to capture. Pro tip: if you notice unwanted color patches appearing in your selection, try adjusting the saturation slider. This helps filter out interference and makes your color extraction more precise. Finally, for any areas the software missed, use the brush tool to manually fill in details or erase artifacts. This is just like retouching a photo. Once the color separation is complete, it's time to assign our filaments. Now, look closely at the custom color palette. You will notice a column of values marked with a percentage sign. This is the transmission distance, represent for the translucency of the material. It determines how light blends through the layers. If you are using third-party filaments, you will need to configure these settings manually. Click the Add sign to create a new custom material. You can quickly set the base color by clicking a similar shade on the color palette, or by entering a specific 6-digit hex color code for precision. Once the color is set, simply input the TD value. The software will automatically convert this into the necessary translucency percentage. You might be wondering, what exactly is the TD value? So, think of it as a measure of how deep light can travel into the plastic. For example, the same light source might penetrate 8 millimeters deep into a white filament, but only 0.6 millimeters into a black filament. Where can you find this number? First, manufacturer data. You can often check the technical specifications provided by the filament manufacturer. Second, community databases. You can search online filament profile databases, like the one shown here for crowdsourced values. Enter the manufacturer's name into the brand selection field. Locate the corresponding filament type in the filament column. Now we can see the corresponding TD value. If you can't find the exact data, don't worry. We recommend downloading a TD test card from MakerWorld. Simply print this tool to measure the approximate TD value of any filament you own. Of course, we want to save you the trouble of manually searching for or measuring these values. To ensure your results match the preview, our laboratory uses professional densitometers to precisely measure the light transmission of filament samples printed at a standard thickness of 0.08 millimeters. Why 0.08 millimeters? This is the standard layer height used for high-quality filament paintings. By matching our test data to the actual print settings, we ensure that the digital preview perfectly reproduces the look of the physical object. We have pre-measured the transmission distance data for all Bambu Lab PLA basic and matte filaments. All of these are already built into the filament library. Just simply select the corresponding model from the list to guarantee the most accurate color blending and performance. With the color parameters set, let's apply the final touches. Use the exposure and contrast sliders to enhance the details. Your goal is to make the parrot's feather texture sharper, ensuring the highlights pop and the shadows have distinct depth. You can apply this same fine-tuning method to the background layer to ensure the whole image is balanced. Once you are satisfied with the preview, scale the model to your desired size. Click Export Model, and be sure to select the correct printer model and nozzle size for your machine. Next, launch Bambu Studio and import your newly generated model file. Double-check that your printer, nozzle, and filament settings match your project configuration. When you're ready, simply click Slice Plate in the top right corner to generate your G-code. After slicing is complete, use the vertical slider on the right to preview the print layer by layer. This allows you to clearly see the color distribution and ensure every transition is correct. Once confirmed, you are ready to initiate printing.
Congratulations! You have successfully completed the advanced course. You have gone from learning the basics all the way to mastering the complex art of relief filament painting. The canvas is now yours.